So in section 4.5, we've got two more triangle congruence theorems. We're going to learn the ASA theorem and the HL theorem, angle side angle and hypotenuse leg for a right triangle. Any triangle, only a right triangle. So let's cover these, and then we'll do a couple examples of proofs with these. So ASA theorem, we've got two triangles, and what here we're calling them ABC, DEF. Okay, so we're doing a proof of this. So we're given AC congruent to DF, B to E, and C to F. So let's put our statement statements and reasons. So first of all, we have our given. We have angle B congruent to angle E, angle C congruent to angle F, and AC congruent to DF. All that is given. Now remember, we're trying to show the two triangles are congruent, and we can use stuff we've learned before, and that's what we have to do. We're building new information upon prior. We're getting a good logical structure and seeing how one thing comes from another. That's an important thing to learn in geometry. It's important for law, politics, physics, economics, business. So the skill that you learn in geometry can be applied in all areas of life. It's up to you to do that with what you're interested in. But we know that this is a triangle, and so the angle's at 180. That's a theorem we've already had. And remember, we've got the theorem that says if two angles of one triangle are congruent to two angles of another, then the remaining angles are congruent. That was in our chapter about parallel lines. It's the third angle theorem. Let me see. Maybe I just passed it up. Okay, properties of parallel lines. I think it's in 3.4, sure enough. Corollary 1 of 311 on page 94. So I'll just call it the third angle theorem, third angle corollary. So we know that this is congruent to this. Angle A congruent to angle D. Corollary to 311. I'll just call it third angle theorem because it sounds nice. Now, hey, look what we got. We're trying to show triangles are congruent from what we started with, but now notice we have angle side angle, angle side angle. A pair of angles that are congruent, a pair of sides, and another pair of angles. And notice it's angle side angle. The side is part of each angle. This side is a part of each angle. So we can use the angle side angle because it's the included angle. Remember, we go, if we call them out in order as we come to them, angle side angle, it's the correct thing. This would be angle angle side, or angle angle side. We have angle side angle, so it's a prior theorem. So we're done. 3 steps. Nice. Triangle ABC is congruent to triangle DEF, angle side angle theorem, or in this book, angle side angle postulate. So that's the first theorem. And so this, notice the angle side angle theorem, AAS, comes from the ASA theorem. An easy application. We put together the fact that the triangles add to 180 with angle side angle theorem, and we get the angle angle side theorem. Now let's do the next one in this section, hypotenuse leg. So we're going to start with two congruent triangles, ABC, and where's the A? Okay, A, B, C, and D, E, F. And we're given the hypotenuse are congruent, and one of the legs is congruent. And of course, we know to have an hypotenuse, it's got to be a right triangle. So we have two right triangles. So we want to show this one is congruent to this one. And all we know is that if it's a right triangle, the hypotenuse are congruent, and a leg is congruent. Okay? A pair of hypotenuse and a pair of legs. So, let's work this out. The idea here, if we get one of the triangles, ABC, and put another one next to it, so this one, flip around, put here, these will match up. BC and EF are the same length, so we can put E on top of B and F on top of C, so these match up, and then D would be around over here. So we got that, we have two right angles, this is the same as this, and so if we look at what we make, we have an isosceles triangle. And we've already had theorems about isosceles triangles, and we know that when two sides of a triangle are equal, then the base angles are equal. So that will equal that. And then we can use the angle side theorem, angle side, to show that the two triangles are congruent. Because we have a pair of angles, and the next thing we come to is another pair of angles, and then a pair of sides. Angle, angle, side. Calling them out in order as we find them. Okay, so that's how we're going to prove these are congruent. So let's just write it up. So first of all, we'll put the given. We have a B congruent to DE, and we have BC congruent to EF. Step 2, we know by the isosceles triangle theorem that angle A is congruent to angle D. So congruent sides in one triangle implies congruent angles in that same triangle. The opposite angles, the base angles. And so then we know angle C and angle F, we'll call 1 and 2. So we don't confuse anything down here. Angle 1 is congruent to angle 2. Definition, right triangle, because one of the angles has to be a right angle, and it's that one. We're given it's that one. And so then we have everything we need. Angle, angle, side. So we conclude triangle ABC is congruent to triangle DEF by the angle, angle, side theorem, which we just proved. Okay, good. So let's try a couple examples. Try some of the ones in the book. So, see, page 142, number 10. So we're given a diagram like this, A, B, C, D, E. And we're given AC, or AB, is congruent to DC. And AC is congruent to DB. So, this whole thing and this whole thing, I'll just mark it like that, knowing what we're talking about. And now we need to prove some triangles are congruent. So let's see if we can do it. So let's see if we can show that this one is the same as this one. And so, because it says we have overlapping triangles, so that's what they're talking about. So for number one, we put our given. So we're going to say a B congruent to CD, and then a C congruent to, kind of a point there, what are we calling that? Oh, it's going all the way up. Jacked it up. Sorry. There we go. Okay. Better. PD. That's given. Then we see that in this triangle and in this one, they both share this. My finger went over this when I did each triangle, so we know they have in common. It's the third side. So BC congruent to itself. You can call that reflexive of congruence or identity. And therefore, we have a pair that's congruent, another pair this congruent with this, and this is congruent with itself. So we have the side, side, side theorem. So triangle ABC is congruent to triangle DCB by side, side, side.